So beginning with exponential functions, our standard equation is y equals b to the x. So if b is greater than 0, you will have a graph that goes up, and if 0 is less than b, and b is greater than 0 but less than 1, you'll have a graph that opens like this. Your y-intercept with the standard equation is 0, 1. You have a horizontal asymptote of y equals 0. You have a range from 0 to infinity in the domain of negative infinity to infinity. And some transformations for another standard equation, f of x equals a to the x plus c, in parentheses, then plus or minus b. For c, if it's positive or negative, you get a horizontal shift. If it's a positive or negative b, you get a vertical shift. And if a is negative, you get a reflection over the x-axis. And if x is negative, you get a reflection over the y-axis, so it'll be up here. Moving to the natural growth, the equation is y equals e to the x. And you have a y-intercept of 0, 1, horizontal asymptote of y equals 0. A domain of negative infinity to infinity, and a range of 0 to infinity. It looks just like the graph of y equals b to the x. And something that's important is finding the inverse. If you're given the equation y equals 2 to the x, finding the inverse, you'll switch the x and the y, giving you x equals 2y. And using our properties of log, we know that the log, if you take the log of both sides, giving you log of x equals log of 2 to y, and your y goes in front of the log, simplifying, dividing both sides by the log of 2, you will get your inverse function of f of x. The inverse of f of x equals the log of x over the log of 2. Moving over to logarithms, if you have the function f of x equals log base of a to the x, which is the inverse of y equals a to the x, and this is what your graph will look like. Transformations, if you have a positive and negative c, it moves the graph left or right. If you have a positive or negative b, your graph goes up or down. Moving to the natural log, if you have the f of x equals log base e of x, which is the same as the natural log of x, and is the inverse function of e to the x, which this is what that graph will look like, f of x of the natural log of x. And going over to the properties of logs, when you have a base b, for standard equation log base of a to the x, what will be log b x divided by log b over x. If you want it, I'm sorry, actually it's a. If you have base 10, it's like the same principle. You get log base 10 of x divided by log base of 10 divided by of a divided by that. Same thing occurs if you have the base e. This time you just take the natural log. So it'll be the natural log of x divided by the natural log of a. Going to the product property, whenever you have an equation it's log a, or the base is some number, if you're doing properties, the product property, so it'll be two numbers multiplied by each other, which simplifies to addition, which is the log base of u plus log base of v. The quotient property, if you're dividing, it's the same as subtracting two logs from each other, so it'll be log base of a u minus log base of a v. Power property, if you have a log base a and a number raised to a power, that power comes in front of the log before the log, so you get n log base a of v. And an example, like it will ask you to solve, you have e to the negative x equals e to the x squared minus 6. You'll take the natural log of both sides, giving you negative x equals x squared minus 6. You move your x over, getting you to a quadratic form. You can simplify and solve for x. In this case, x equals -3 or 2. And this gets us to our one-to-one function. And for y equals x, for every value of y, it is the same value of x. So this is why we're able to do this. Another problem, using our properties of logs, we want to simplify this. So the same thing as addition is multiplying. So you have log base 10 of 8 plus log base 10 of 8 is the same as multiplying. So you get log base 10, which is 8 times 8, and you get the log base 10 of 64. Again, this is doing subtraction, which is the same as division. So you get log base 10 of 16 over 4, giving you log base 10 of 4. That's about it.
Done?
Yep.
Cool.